this problem part 5. Okay, so 5, you have u sub n plus 1 is equal to u sub n cubed plus 6 over 7. Okay, with different initial conditions. U sub 0 is 1/2, u sub 0 is 3/2, or u sub 0 is 3. Okay, and we will see that the different starting points of the sequence will lead to different limits or convergence conditions, in a sense. Okay, so let's start with the first one. U sub 0 is 1/2. Okay, so the first part is as usual. We assume that the sequence has a limit. Let's say the limit when n goes to infinity of u sub n is u, and then we compute it using this recurrence formula. So taking limits in both sides, we have this, which is the same as saying that u cubed minus 7u plus 6 equals 0. Okay? Now, how do we get the roots from this polynomial? This is a third order polynomial, and there is no general formula. Well, there are general formulas, but we are not going to see them. But a kind of rule or trick to try to test different roots is what's called Ruffini's rule. Okay, and I hope you guys have seen this in high school, and if you haven't, you can look it up in Wikipedia, for instance. Okay, on the internet, there are many resources to learn about it, or you can ask me about it. You can send me an email or something. But I'm assuming that you know how to work with this. Okay, so in order to work with Ruffini's rule, we write this the coefficients of the polynomial, and then we try different roots. Okay, the first one. So we know that the roots, if they're integer, and I can assure you they're going to be integer, but because otherwise it's going to be hell to get them. For the first one, so okay, yeah, sorry. So the roots have to be divisors of 6. Okay, so it's either plus 6, minus 6, plus minus 3, plus minus 2, and plus minus 1 if they're integer. Okay, and because of this form, okay, it's 1 and then minus 7. If you sum 1 to this, it's going to be minus 6 and then 6. So I'm going to try 1. Okay, so it's 1, it goes down, you multiply 1, you sum, multiply again, and then just like I wanted, and then you get 0. Okay, the last one here is the remainder, and then you get 1, 1 minus 6. Okay, and then you hear this is a second order polynomial. This is u squared plus u minus 6 equals 0. So then you can get the roots with solving this equation, as we already know how to do. But I'm going to try to follow this up. And so if you try, for instance, 2, there's 2, yes, you get, 1, 1, and then you multiply it by 2, and then you get 3. 2 times 3 is 6, which is what you want. And then the final root is minus 3. Okay, this is the last polynomial is u plus 3. Okay, so you can factor this as u minus 1, u minus 2, u plus 3 equals 0. Okay, so the 3 roots are either u equals 1, u equals 2, or u equals minus 3. 3 possible limits. Okay, in case that the sequence is convergent. Okay, so now if we started 1/2, okay, I'm going to try and see if I can prove that the sequence is between 0 and 1. Okay, if it's bounded by 0 and 1. Okay, let's see. So for u sub 0 is greater than 0, that's true. Let's assume it's true for u sub n, and what happens with u sub n plus 1? Okay, u sub n plus 1 is u sub n cubed plus 6 over 7. If we assume u sub n is greater than 0, then this is greater than 6/7, which is greater than 0. Okay, so we have proved it. And then is it smaller than 1? Okay, u sub 0 is 1/2. This is true. Okay, and then what happens with u sub n plus 1? Well, again, we have the recurrence formula. If this is smaller than 1, then this is smaller than 1 plus 6 over 7, because u sub n smaller than 1 means that u sub n cube is smaller than 1 as well. So this is 1 plus 6, 7 over 7, this is 1. So this is smaller than 1 as we wanted to prove. So we have just proven that the sequence is bounded between 0 and 1. Okay, so now in order for us to test that the sequence is convergent to the only possible limit that could be here is 1, we need to prove that the sequence is increasing. Okay, so is the sequence increasing? Well, as we have done before, we compute u sub n plus 1 minus u sub n, and then we have u sub n cubed plus 6 over 7 minus u sub n, and then you have minus 7 u sub n plus 6 over 7. So again, the same polynomial as before, as we have seen, and we know we can factor this with this root. So this is u sub n minus 1, u sub n minus 2, u sub n plus 3, okay, over 7. So now u sub n minus 1 is smaller than 0, because u sub n is always smaller than 1. U sub n minus 2 is smaller than 0 again, sorry, smaller than 0. And then u sub n plus 3 is greater than 0, because u sub n is positive. So then we have negative, negative, positive. We have a positive denominator and a positive, positive numerator and positive denominator. So this is greater than 0. So again, if u sub n plus 1 minus u sub n is greater than 0 for all n, this means that the sequence is increasing monotonically. So it is monotonically increasing, it is bounded above by 1, and we know that, this means that the sequence will have a limit, and the limit, the only possible one that can be if the sequence is bounded between 0 and 1 is 1. Okay, so the first case, we're starting with u sub 0 equals 1/2, the limit is 1. Okay, now let's do it for b. The limit is 3/2. Now I'm going to try and prove that the sequence is bounded between 1 and 2. Okay, so that you know that the bounds are different. So u sub 0 is greater than 1, yes. And now what happens with u sub n plus 1? We assume that u sub n is greater than 1. So if this is greater than 1, then this is greater than 1 plus 6 over 7, 1 greater than 1. Okay. And then u sub 0 is smaller than 2, okay. And we assume that u sub n is smaller than 2. Now what happens with u sub n plus 1, the second step of induction? So if this is smaller than 2, then this is smaller than 8 plus 6 over 7. This is 14 over 7 is 2, which is what we wanted. Okay? So yeah, sorry, sometimes I write this 1 plus 6 over 7 is equal to 1. Okay, so I just made a mistake. Sometimes I write in fast, but you should read it like this: u sub n plus 1, which is equal to something that's greater than, and then 1. Okay, so u sub n plus 1 is greater than 1. You read it like that. And here too, u sub n plus 1 is smaller than 2. Okay, so we have proven that the sequence is bounded between 1 and 2 for all eternity. So now what happens, is the sequence increasing or decreasing? Okay, if it's increasing, then because it is bounded between 1 and 2, the limit will be 2. And if it's decreasing, the limit will be 1. So we just need to test it again. So, and then we have, as before, we have u sub n minus 1, u sub n minus 2, u sub n plus 3 over 7. Okay, now u sub n minus 1 is greater than 0, because u sub n is between 1 and 2. U sub n minus 2 is 0, sorry, smaller than 0, and u sub n minus 3, sorry, plus 3 is greater than 0, because u sub n is always greater than 1. So this is positive, negative, positive. We have a negative numerator, so this is smaller than 0, so the sequence is now decreasing. Okay, so it's a decreasing sequence starting at 3/2. It goes down all the way to 1. So again, the limit is 1. Okay, And now let's do the last one. So C u sub 0 is 3. Okay, so in this case, it looks like the sequence is going to be different. Okay, it's going to grow somehow. So because again, so this is u sub n plus 1 minus u sub n. This is u sub n minus 1, u sub n minus 2, u sub n plus 3. Okay, over 7. Okay, we can prove that u sub n is greater than 2 for all n. It's easy to prove. So assume u sub 0 is greater than 2, and assuming u sub 1 is greater than 2, then u sub n plus 1 is again u sub n cubed plus 6 over 7. This is greater than, again, 8 plus 6 over 7 equals 2. So this is greater than 2. The sequence is greater than 2. Okay, so in this case, u sub n minus 1 is positive, u sub n minus 2 is positive, and u sub n minus 3 is positive. So the sequence is increasing. Okay, so now the sequence starts at 3, it increases from 3, and we don't know if it has any known bound. But if it was bounded, as we had seen in part 4, if it was bounded, it would mean that the sequence would have a limit because it is monotonically increasing. Okay, but the only limits it can take are 1, 2, and 3. But the sequence is always greater than these guys, and it's increasing. Okay, so this cannot be true. This is a contradiction. So the sequence has no limit. The sequence is divergent. Okay, it can have no bound, no upper bound. It grows up to infinity. Okay, and so that's the end of this problem.